Okay, in this section we want to look at a system of linear equations. So the first thing that we want to look at is where would a possible solution be when we have a system of linear equations. The easiest way to think about this is to think about it graphically. So if I have two lines and I want to know where their solution would lie, I could also think about where the lines would be intersecting. So I look at this first example. A solution is going to be where the lines are intersecting. Okay, so I would get an ordered pair in x, comma, y. Now, I could have a situation where I graph two lines, or I have two equations of lines that never intersect. So of course, that's what we call parallel lines. So in that situation, we would have no solution because they're never going to intersect. That would be our next kind of example here. And then the last type of solution that we could get is, what if I graph the two lines, or I have two equations and they end up being exactly the same. So I graph one line, it ends up exactly on the other line. We say that, well, where are they going to cross? Always, infinitely many times. So that means we would have infinitely many solutions. So we could have one solution where they cross, no solution where they never cross, or infinitely many solutions where it is the exact same line. Okay, some more vocabulary that we have for that, if we kind of look at the top here. If we have one solution or intersecting lines, we would say that it is a consistent, independent system. If they never cross, or we have no solution, parallel lines, we could say that it is inconsistent. If they cross and they're exactly the same line, so we have infinitely many solutions, we would say it is consistent and dependent. Okay, so that's just kind of some vocabulary for us here. Right? So if that is the case, and we can automatically tell once it's graphed what the solution is, or if there even is a solution, then of course one of the ways to solve a system is to graph them. So we're going to graph each line, and then we're going to find the intersection, or if there is no intersection, describe if it's a no solution, inconsistent, or infinitely many, consistent and dependent. Okay. Now we have to remember how to graph a line. So I kind of gave you a little hint here. Remember, if it's in the form y equals mx plus b, right, we would start with our y-intercept, and then we would move to our slope. Remember that our slope is that rise over run. Okay, so let's look at our first example here. All right, so in this first example, I'm going to need to solve them for y first. So I'm going to solve this first equation. I'm going to have x minus y equals 3. I'm going to move that x to the other side. And then I'm going to divide by a -1. Remember, dividing by -1 just changes all of my signs. So I'm going to have x minus 3. Okay. Once that equation is solved, I can go graph it. My b, or my y-intercept, is at -3. And then my slope would be 1, which means I'm going to rise 1, run 1. So from this, I'm going to go up 1 over 1, up 1 over 1 throughout the entire graph here. All right, so I kind of get the idea here going. And let's see if I can draw a pretty straight line. It's pretty straight. Okay, so same idea. We're going to do this with our other equation. All right, so I need to solve that for y. So I'm going to move that 1/2 x over. So we have a -1/2 x plus 3. So that means that my y-intercept is 3. My slope is a -1/2. So I'm going to start at 3, and I'm going to go down 1 over 2, down 1 over 2, down 1 over 2. And then if I connect those. All right, so I can tell now that these are intersecting lines, which means I should have a solution right where they intersect. So I look at that intersection and I see that it is at 4, 1, so my solution would be 4, 1. Okay. Let's try another example, make sure we kind of got the hang of it. Solve that first equation for y. So I'm going to move that 2x over. Divide by that negative 1. So I'm going to change all of my signs here. All right, so I'm going to have a y-intercept here of negative 5, a slope of 2. So I'm going to start at negative 5, and I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. Remember, you could also reverse that down to left 1, down to left 1, right? Kind of get our graph going there. All right. Next line, I'm going to solve it for y again. I'm going to move that 5x over. 2y equals negative 5x plus 8. And I always typically just go ahead and put the x in the beginning because then it's easy for me to see that y equals mx plus my b, right? So I'm going to begin at 4, and I'm going to move to a negative 5 over 2. So I see that they cross, which means I can find their intersection. And so I should get 2, negative 1, right? So that's how we would solve a system by graphing. Okay, the next way to solve a system of linear equations is to solve it by substitution. And it's just that. We're going to substitute, plug back in. Okay, so the first thing that we're going to do, we're going to pick an equation and solve for a variable. It doesn't matter which equation that you pick. I always just go for the easier one. What I mean by an easier equation is that when I solve for the variable, I don't get fractions, right? So I try to first find an equation with a variable with no coefficient. Typically is going to be an easier route to go, okay? Now, once I have solved the equation for that one variable, I'm going to plug it into the new equation, the one that I have not solved yet. Once I do that, I'll have one equation with one variable, and I'll just do my regular solving. I'll do my PEMDAS. I'll do my moving the variable to one side, constants on another, whatever. And I'll get one of the variables. I will take that and plug it back in. So the steps kind of seem ambiguous right now, but let's look at an example, and I think it'll make a little bit more sense. So the first thing, remember, I want to pick an equation to solve for one variable. So I'm going to pick this bottom equation, and I'm going to try to solve it for y. The reason I want to do that is because I noticed there is no number in front of the y. So what that means is when I go to solve this equation for y, all I have to do is subtract that 10x, and I will be solved for y. So I always go for the least amount of work. That's my goal. All right, so now that I've got y solved for, I'm going to take that and I'm going to go plug it back in to the equation that I have not used. Okay, so what that's going to look like, I'm going to start writing my equation. 2x minus 3 times y equals negative 1. Now notice when I said the letter y, I wrote open parentheses. In that open parentheses, I'm going to plug in that negative 10x plus 11. Because that's what y is equal to. All right. So now that I've substituted, I've plugged in, I'm going to do my solving. Okay, so it's just like my PEMDAS and regular solving. So I'm going to distribute here. I'm going to combine my like terms. So I've got 32x. 33 equals negative 11. I'm going to move that 33 to the other side. Okay, then I'm going to divide. I get 22 over 32. I can reduce that to be 11 over 16. Now you're like, oh, that's ugly. And that is exactly why sometimes we don't always want to graph, right? Sometimes when we go to graph something, it's not on those nice, real pretty points and I can tell exactly where the intersection is. I can physically see that they cross, but I can't find the ordered pair because it's some decimal. So that's why we want to use substitution, because now I can easily find this kind of odd fraction. I get that number, and I'm going to take that number back to where I was solved for y. So I was here solved for y equals, right before I went to substitute. So I'm going to go back and I'm going to plug in x into that equation. So I have y is equal to a negative 10 times 11 over 16 plus 11. And you're right, it's like, oh, it's kind of an ugly number. Okay, sometimes numbers are just ugly, and it just really is what it is. Okay, so when I plug that in, I'm going to get that y is equal to either 33 over 8 if you're keeping it in fractions, or you could say it's 4.125. Doesn't matter on these if you write them in decimal or fraction, whatever you want to do. I like to keep it constant though. So if I have a fraction of the first one, I'm going to leave the fraction of the second one. It doesn't matter. So then I would write my answer as that ordered pair, 11 over 16, comma 33 over 8. All right. So let's follow these steps and do another example. All right. So I look at my equations and I say, okay, well, which equation is going to be the easiest to solve? I'm going to go with my first equation and I'm going to solve it for x because, again, there's nothing in front of the x. So it's going to be really quick and easy to solve. So all I would do is I would move that negative, I would make that 2y negative, move it to the other side. So I get x is equal to a negative 2y minus 4. I'm going to take that and I'm going to plug it back into my untouched equation. So I'm going to have 2x minus 4y equals 16. Remember, I said x, but I wrote an open parenthesis because what's really going to go in there is that negative 2y minus 4. Right? Remember, we're going to plug in what we just found there. Right? So now at this point, it's going to be some PEMDAS. I'm going to distribute. We got negative 4y minus 8 minus 4y equals 16. I'm going to combine my like terms. Negative 8y minus 8 equals 16. Keep solving it here. Negative 8y equals 24. Divide. So y is going to equal negative 3. Hey, that was a nice, pretty number. Okay, great. They don't all have to be ugly. Okay, so I'm going to take that number, y equals negative 3, and I'm going to go back to where we had solved for x here, right? So I'm going to say now x is equal to a negative 2 times that negative 3 minus 4. So x is going to be equal to 2. So now I've got my two solutions. So I'm going to write it as my ordered pair, 2, comma, negative 3. All right, and that's how I'm going to solve by substitution. Okay, the last method is to solve by elimination. Sometimes it's also called the addition method. Some books call it one thing, some books call it another thing. Probably in high school, most of you learned it as elimination method, but either way. So in this method, what I'm going to try to do is I'm going to try to cancel off a variable by adding them together. What I mean by that is if I wanted to cancel off, let's say, a 7x, I would add it to a negative 7x, right? Because then those two things would cancel. If I was trying to cancel a negative 3y, I would add it to a positive 3y because those would cancel. So when I talk about I want to pick a variable to cancel, what I'm trying to do is pick a variable to where I'm going to be able to have the same number with opposite signs cancel. Now, when I look at something like that, say I had a 3y and a 6y. Oh, well, they're not going to cancel, right? But if one of them, let's say this 3 got multiplied by a -2. So let's say we multiply it by -2. Now I have a -6y. Now those are going to cancel. So that's what I mean by we might need to multiply an equation by a factor to be able to cancel it. Okay? So we'll look at that a little bit more. Once my variables have the same number but opposite signs, I'm going to add them together for them to cancel. Okay. When I do that, it'll be a quick, easy solve. And then I'm going to take that number that I get and go back and substitute it back in, just like what we did on the last problems. All right, so let's kind of look at one. Again, the steps kind of seem ambiguous until you actually see it at work. So let's take a look at this first example. So when I'm looking at these, the first thing that kind of I notice is that I have a 3 and a 5, which the least common multiple there would be 15. So that means I would have to multiply the top one by a 5 and the bottom one by a 3 so that they would both be the same number. Okay, so I'm like, okay, well, I could do that. Let's see if y is easier. So I see a 2 and a 10. Well, what if I just multiplied the top equation by 5? Then I'd have a 10 and a 10. Oh, I only have to do one multiplication step, so it's a little bit easier. So I'm going to pick y's to eliminate. Okay, so I'm going to pick the y's. Again, you can pick whichever one you want. I just typically try to go for the one with the least amount of work. So when I pick y's, though, I'm going to have to multiply that entire equation by a 5 so that I actually get a 10 in that top equation. So I'm going to distribute. So I'm going to get 15x minus 10y equals 0. Because, right, 5 times 3 is 15, 5 times 2 is 10, 5 times 0 is 0. So now I did nothing to the second equation. Okay. Now I can move on to step 2 that says, okay, now I can add these two equations together. 15 and 5 makes 20x. My y's now cancel. 4 plus 0 is 4. Okay. So now I'm on to step 3. I'm going to solve the remaining variable. Pretty simple here. I'm going to divide by a 20. And I just went ahead and reduced that there. Again, you're like, oh, it's not a very pretty number. That's fine, because not all numbers are going to be pretty. All right. So I have my x to be 1/5. I'm going to take that back to any of the original equations. So I can either go back to my 3x minus 2y equals 0, or I can go back to my 5x plus 10y equals 4. I like smaller numbers, so I'm going to take this back to my first equation. So I'm going to say 3 times my 1/5 minus 2y equals 0. Okay. So I'm going to have 3/5 minus 2y equals 0. I'm going to subtract that 3/5 to the other side. And then I'm going to divide by a -2. So I get positive 3/10. And again, since my original answer was in a fraction, I'm going to leave my second variable in a fraction. Doesn't matter, it is up to you. So I see my solution now is 1/5, comma 3/10. Okay. So I tried to pick an example from the last one and this one where they weren't all that pretty, so that you could see, okay, oh, if I get a fraction, I must have done it wrong. No, I can get a fraction and still have the right answer, okay? They don't always have to look pretty, all right? Let's try this last example here, okay? So we're going to look at the two equations, and we're going to try to decide which variable that we want to get rid of. So let's kind of talk through each variable, and then we'll make our decision. So if I look at the first variable, I've got a 3x and an x. So for them to cancel, I would need a 3, right? Because I could multiply the bottom equation by a -3, and then I have a +3 and a -3. That doesn't seem too bad. I'm only multiplying one equation. Let's look at the next variable just to make sure that x is our best route. Okay, so I've got a 2y and a -7y. So the least common multiple there is going to be a 14. So I'd have to multiply the top equation by 7 and the bottom equation by 2. So even though one's already positive and one's already negative, I still have to multiply two things instead of multiplying only one thing, looking at the x's. So I'm actually going to pick my x on this one. And I'm going to have to multiply that bottom equation by a -3. So I'm going to distribute that here. So I'm going to have -3x plus 21y equals 90. Now it's kind of all jumbled up, so I'm just going to go ahead and rewrite that top equation that I did nothing to, just so it's a little bit more clean here. Remember, I didn't do anything to it, I just rewrote it so they'd kind of line up nice and pretty. All right, so now that they are the exact same variable, or excuse me, they're the exact same number but opposite signs, I can add them together and that variable x should cancel off. All right, so I'm going to have 23y equals 92. Right? So then from here, I'm going to continue to solve. So I'm going to divide by that 23. Y is going to equal 4. Hey, that was a pretty number. Okay, great. They could be pretty. All right, so I'm going to take that back to either of the two equations, either my 3x plus 2y equals 2, or my x minus 7y equals -30. Again, it's up to you. I like smaller numbers, so I'm going to use that first equation. So I'm going to say 3x minus 2 times 4 equals 2. So I got 3x minus 8 equals 2. Add that 8. 3x equals 10, divide by 3, x equals 10 thirds. So, oh, man, we got a fraction. Okay, like it is what it is. So I've got my ordered pair, 10 thirds, comma, 4. All right, and that's how you're going to solve by elimination. So now we've seen all three ways to solve a system. The whole goal is to use whichever way is going to be easier for you to solve.